For as young as I can hold a screwdriver, I've always taken apart my toys when I was young, and because I was always curious. Everything that touches our lives, including your smartphone, the computer that you use, the vehicle that you drive, everything around us, the airplane that you fly in, that you travel in, was all in one form or another designed by a mechanical engineer. Hi everyone, thanks for tuning in. My name is 𝐂𝐿, and I'm one of the co-founders and engineering principals here at Hatch Duo. In the previous episode, you had heard from John about the value of design, but today I'd like to talk lightly about the value of engineering. So first of all, what is mechanical engineering? The US Bureau of Labor and Statistics defines mechanical engineering as developing, testing, and building mechanical and thermal sensors and devices. I personally think it's much more than that. Mechanical engineering as a study covers a wide array of specialties, including medical devices, research and development, materials, automotive, you name it, consumer electronics. As we've mentioned before, both industrial design and mechanical engineering go hand in hand, especially with early stage product development. Oftentimes, clients have trouble differentiating between engineering and industrial design, mainly because they're so closely related. But I'll try to break down the roles that we play. ID usually leads a project, and midway through, when we reach the design for assembly phase, the mechanical engineering phase usually occurs. And so what typically happens then for the products that we work on is, we apply design for assembly methodologies. What does that mean? What is DFA? What is design for assembly? What that means is, if you've ever taken apart a consumer device, you might notice that there's electronics, there's batteries, there's wires, LED lights, what have you, within these devices. And basically, design for assembly is figuring out how to piece the puzzle together. So if you imagine your product to be a giant puzzle, you figure out how, where you have male, female features, where you have hardware that attaches, your PCB components, your lighting components, if you have lenses. We figure out how all the parts come together and stay together. There's a lot of consideration that's taken when it comes to hiding hardware so it's not visible, and it maintains, the industrial design vision. Generally, we partner and we work closely with electrical engineering stakeholders and other subject matter experts to ensure that all the electrical components and layouts are met, other requirements are met. And that generally means, if there's antennas, that there's no metal obstructing it, that would cause interference with communications, with wireless communications. Once you complete the DFA phase, then what we normally do is we roll into prototyping. One of the most prominent methods that we use today is obviously 3D printing. And with 3D printing, there's a vast array of material options. Some of the notable materials that we like to print with is SLS. It's a selective laser sintered material for nylon. You can get glass-filled nylon, various forms of nylon mixtures, and multi-jet fusion, which is another form of nylon. And the latest method that we've used is directed energy deposition, DED, and that's primarily for 3D printing composites. So one of the advantages of rapid prototyping is that you can get quick turn parts in a matter of days. And what that really is helpful for is accelerating the development schedule and identifying issues or fitment issues that you might have between each part. With the fit up and testing, we're able to quickly identify where these interferences or looseness might occur. We can make changes on the fly within the CAD model in a matter of hours and produce the next revision. So you can see how this might be very advantageous when it comes to accelerating product development, because you can quickly iterate and refine your model. What are the advantages of integrating mechanical engineering into the design process? I think there's opportunity to de-risk a lot of issues that might occur if they were not discovered early on, and it would be more costly if discovered later on in the production process. So take, for example, without going through the design for assembly, design for manufacturing phases in product development, and if you bypass all that, you go straight to manufacturing, get ready to open up a can of worms with your supplier. At Hatch Duo, we're in the business of shipping products, not just creating ideas. And we need engineers to be able to get these ideas and products to market. If you found this video useful, please like, comment, or subscribe below, and we'll be sure to publish more content for you.